Welcome to the Top 5 Auto Advice. Most modern automobile engines are equipped with a variety of sensors, which collect data and calculate the ideal air-fuel ratio for the best performance and fuel efficiency under all conditions. There are three categories of sensors: sensors for controlling the engine, sensors for the body, and sensors for various other parts like the brakes, suspension, and transmission. Several sensors on the engine send data to the Engine Control Unit, or ECU. Compares those details. The first crucial sensor is the crank position sensor, which is typically found in the crankcase over the toothed wheel on the crankshaft. It monitors the piston's TDC position in the engine and also measures the crankshaft's rotation speed. The sensor outputs are then sent to the spark plugs, fuel injectors, and other components to allow the engine to run as efficiently as possible. With pistons, let's look at the cam position sensor. The engine's rotational speed is calculated using the rate of positional change. The third sensor is the mass airflow sensor, which is situated between the air filter and the engine's intake manifold. The mass airflow sensor's job is to determine the precise position of the engine's camshaft and valves. It works in conjunction with a crank sensor to ensure perfect ignition timing. If these sensors malfunction, the engine cannot be started. The ECU uses the air measurement during the intake stroke to determine how much fuel needs to be added for the ideal air and fuel mixture to achieve better results. In order to calculate the pressure of air going to the engine, a device called a manifold absolute pressure sensor, also known as a MAP sensor, is located in the intake manifold. It works similarly to a mass airflow sensor, which measures the mass flow of air, and a MAP sensor measures the pressure of air. More fuel can be used because air will have a higher mass at higher pressures. This sensor aids the ECU in determining how much fuel and air should be sent to the engine. A knock sensor, which is commonly found outside the engine block. Knocking indicates that the ignition started before the actual time, which results in an engine that vibrates and sounds loudly. The knock sensor detects the high-frequency knocking engine vibration and sends a message to the ECU. Cool and temperature sensor. A car engine produces a lot of heat when it is running and must be continuously cooled to prevent engine damage. Typically, this is done by circulating coolant liquid through passages to the radiator. When the ECU receives an electric signal, the ECU returns the ignition timing and stops the occurrence of knocking inside the engine, improving the economy and power of an engine. The radiator has tiny metal fins that increase the radiator's surface area in contact. The coolant temperature sensor is situated between the engine and radiator passages. It monitors the temperature of liquid coolant and sends a signal to the ECU, which uses this reading to calculate the coolant temperature. The radiator also houses an electric fan that transfers heat from radiator to the atmosphere, causing the coolant in radiator to cool down and be sent back to the engine, and this process repeats. Fuel temperature sensor measures the fuel's temperature and transmits the signal to the ECU. Warm fuel is less dense and burns more readily, so the ECU injects more fuel. Cold fuel is denser and takes longer to burn, so the ECU injects less fuel. This information is also used to send an accurate reading of the engine temperature to a gauge on the dashboard. This sensor can be found on a send unit inside the fuel tank or on a high-pressure pump that is connected to the engine's crash sensor for airbags in some brands. One of the most crucial parts of your car's safety system is the airbag system. The airbag control unit receives a signal from the crash sensor milliseconds after collision when the vehicle has been damaged, according to crash sensors, which are small electronic devices. When the control unit determines there has been an accident, it alerts the inflator system. The crash sensor is located in the front side of the car behind the bumper, and also inside the side pillars or doors of the vehicle's body. Speed sensor for anti-lock braking system. In this system, the brakes are applied and released numerous times. This all happens in an instant, typically within 25 to 50 milliseconds. The airbag provides a cushioning system for the people in the car and saves lives. The driver can steer the vehicle because of the traction that is available, which aids in avoiding collisions. In a vehicle wheel speed, the advanced anti-lock braking system provides important advantages over standard brakes. All of the wheels have sensors that measure each wheel's speed. Following the speed, the ECU reads the signal from each sensor. Sensors can measure speed. After sending a signal to the ECU once more, which in turn sent a signal to open the valve and increase the brake pressure, brakes were applied. The cycle repeated itself until the application of brakes became normal. Sensors for parking. Parking sensors are proximity sensors for vehicles intended to warn the driver of obstacles while parking. They are sometimes found in the front bumper, as well as the back of some vehicles. Rear parking sensors are activated automatically when the driver shifts into reverse gear. They then send ultrasonic waves. When these waves hit a nearby object, they reflect back and are captured again by the sensors. This process measures the distance between the sensor and object. It then alerts the driver about the distance between the vehicle and object through a dashboard visual and audible indicator. Wiping sensor for rain. The rain sensor, which is located on the upper end of the windshield glass, detects the amount of precipitation and regulates the wiping cycle for the appropriate interval. It sends out a beam of infrared light, which is reflected back at different angles by water droplets on the windshield. This instructs the system to turn on the wipers and modify wiper speed and frequency based on the amount of precipitation and the frequency of the wipers. Automobile speed. The wiper automatically operates more quickly as it rains. If you want to see more videos like this, please consider like, share, and subscribe to this channel. Thanks for watching.